Hi everyone, my name is Vishakha, and today we will be going through assignment 4 for previous year's week 4 microwave antennas course. Okay, for those who have joined for the first time, hi, I am from IIT Bombay. I'm doing PhD. Okay. Hello, Raman. Acha, so you are you have joined for the first time. Okay. So as I was saying, I am doing PhD from electrical engineering, IIT Bombay. My focus is on antennas. So let's study today antennas. Okay. Let me know if you can see my screen. Okay. Can you see my screen, everyone?
Yes, ma'am.
Okay. Very good. So let's start the session. This is for analysis and design principles of microwave antennas. Okay, so let me know if so when is the deadline for you to complete your assignment 4?
Ma'am, tomorrow.
Tomorrow. Okay, all right. So it's good that I'm today I will be telling you the solutions, not the solution for this assignment, previous year's assignment. Okay. So I hope you have gone through lecture number 16 to lecture number 20, right? Okay. So, as I for Raman, so my pattern is that I first explain you the question, then I give you some hints for you to solve the question, and later on we discuss the solution. Okay. So let's start the session. Question number 1.
Okay.
Any doubt, anyone? No. Okay. All right. So. Yeah. So an L is equals to 0.47 lambda folded dipole whose wire radius is 5 into 10 to the power minus 3 lambda is fed with a twin lead transmission line of 300 ohms character. Oh, sorry, 300 ohm characteristic impedance. Okay. The center to center spacing of the two side by side wires of dipole is S is equals to 0.25 lambda. Okay. The dipole is operating at f is equals to 10 megahertz. The input impedance of a regular dipole of length L is 0.47 lambda is of length 0.47 lambda is ZD is equals to 79 plus J30. What will be the input impedance of the folded dipole? So sir would have discussed with you folded dipole, right? Something like this. So this is a folded dipole. So a folded dipole can be then uh, cut into two modes. It can be bifurcated into two modes. One is antenna mode and another is transmission line mode. Okay. So here it's written that a folded dipole of length L is equals to 0.47 lambda. Alright. Whose wire radius is 5 into 10 to the power minus 3 lambda. It is fed with twin lead transmission line of 300 ohm characteristic impedance. Okay. Abhi, the center to center spacing of two side by side wires of dipole is, so here uh, R of dipole is S is equal to 0.25 lambda. So here bifurcate, after bifurcation, anyways, here the spacing is given as s is equals to 0.25 lambdas. Okay. Now it is also said that this dipole is operating at f is equals to 10 megahertz. All right. And impedance of regular dipole. So that means ZD is given as 30, and it is asked what will be the total input impedance of the folded dipole. Got it? So question here says that a folded dipole is given to you. It has a length of sorry, the regular dipole has length of L is equals to 0.47 lambda, and it has a impedance of 79 plus J13. Okay. Now this wire, which is this wire has a radius of 5 into 10 to the power minus 3 lambda. Okay. And it is fed by twin lead transmission line of 300 ohm characteristic impedance. Okay. So all the things are given to you here. What you have to do is, so already first thing is to know is total impedance can be given as, for a folded dipole, total impedance can be given as 4ZT into ZD upon 2ZD plus ZT. Now this ZT is impedance for the transmission line which is connected. So this transmission lines connected with the dipole antennas. Okay. So this is dipole antennas and these are transmission line. Okay. The input impedance of folded dipole can be given as ZA 4ZT into ZD upon 2ZD plus ZT. ZT. Now ZT can be written as JZ0 10 KL by 2. Z0 is, what is Z0? Can someone tell me?
Ma'am, characteristics impedance.
Yes, very good. Yeah. So Z0 is characteristic impedance. So ZT is JZ0 tan uh, KL by 2. Okay. So first what you have to do is find out characteristic impedance. Since here characteristic impedance is not given of these twin lead transmission line. Twin lead transmission lines characteristic impedance is given, but folded dipole does not. It's not given to you the dipole's characteristic impedance. Okay, it's given that it's a side by side wire and it has a center to center spacing of 0.25 lambda. So spacing is given to you, but characteristic impedance is not given to you. So first you find out the characteristic impedance and then put it in the transmission line impedance. Find out the transmission line impedance. You already know the value of ZD. You will be able to find out Z in. That is the of the folded dipole. Got it? Got it? Were you able
Yes,
to?
madam.
Yeah.
Yes, madam.
Okay. So, yeah. So I'm going to give you till here. I'm going to show you till here. Now you have to, from here, you have to find out from Z0, you have to find out ZT. From ZT and Z0 and ZD, you have to find out Z in. Okay. Uh, Here in Z0, S is given to you, value of S is given to you. You already know the value of free space impedance, which is 120 pi, and value of A is given to you, right? Wire radius was given to you, which is 5 into 10 to the power minus 3 lambda. So all the values are given to you till here. You first get Z0, put it here, and you will be able to find out the Z in. Okay. Try to solve this question. I'm giving you 3 minutes. Okay. The options as well. Okay, 1 second. I will show you the options and the. Okay, solve this question. I'm giving you 2 minutes. Sorry, 3 minutes. I'm giving you. Yes, Raman.
या हेलो.
हेलो.
हाय मैम. हाय मैम, रमन बोल रहा हूँ. हेलो. यस.
हाँ हाँ बोलो.
हाँ मैम, मैं ना मतलब मैं फर्स्ट मतलब ज्वाइन किया हूँ, बट मैं कोर्स अभी तक कैसे ज्वाइन रजिस्टर कैसे करना है तो अभी ये तो मुझे मालूम ही नहीं है.
ओके.
तो एक्चुअली मुझे कोर्स ज्वाइन करना था और एक्चुअली मुझे ग्रेस के लिए चाहिए था, मॉक्स के लिए.
क्या चाहिए था?
मॉक्स सर्टिफिकेट जो होता है ना.
हाँ हाँ, मॉक सर्टिफिकेट. तुम
जी
मॉक
जी.
सर्टिफिकेट या तुम्हें एग्जाम रजिस्टर करके एग्जाम देके सर्टिफिकेट चाहिए था कोर्स कंप्लीशन का? मॉक
हाँ
में
जी जी.
ऐसा कुछ नहीं होता. ओके. तो अ, तो मतलब क्या इशू आ रहा है? तुम्हें पता नहीं है कैसे करना है?
हाँ हाँ मैम, ये मुझे नहीं पता है कैसे रजिस्टर होगा, कैसे मतलब अप्लाई करना है. बस तो ये मुझे जानना था.
अच्छा. ठीक है, तो इसके बारे में हम क्लास खत्म होने के बाद बात करते हैं. ठीक है, बाकी लोगों को अभी टाइम वेस्ट होगा ना, हम बीच में बात
हाँ
करेंगे तो क्लास खत्म हो जाएगा तो विल टॉक.
ठीक. ओके ओके मैम. थैंक यू.
done? You need more time? You want to, if you have any doubt, you ask me, okay? Are you done, guys? Chalo, we'll try to solve it. Okay, so here ZIN is the input impedance of the folded dipole, and that is what is asked to you. So first you have to find out the ZT impedance, impedance of the transmission line. So what that will be, it will be J Z naught tan K L by 2. So Z naught here is 120 pi, N by pi. So N is not N. Yeah, this is a free space impedance 120 pi by pi cos H inverse S by 2 by A. So S is 0.025 lambda. So you have to put that divided by 2 into A. A is wire radius, which is 5 into 10 to the power minus 3. So that. So here Z naught is 188.016, which is characteristic impedance. Now that you know that, you have to put this into ZT value. So you will be able to find out ZT value. So you already know Z naught, you know tan, you know K, right? K, what will you write K? K is 2 pi by lambda, right? Propagation constant. So then into L by 2, L by 2 is, L is already given to you, how much? 0.47 lambda. So you put that. So ZT will be how much? J 1989. Did anyone got till here? Till ZT? Was anyone able to get? Okay, all right. So now that you know ZT, ZT is given to you. You put all these values here, and you will be able to find out Zin. So the correct answer is answer C. Right? So 1 3 plus J 75.337. Okay. So any doubts here? Anyone has any doubt here? Okay. All right. So now let's go to question number 2. Here, question number 2 says, consider an isolated resonant lambda by 2 half wave dipole at 3 gigahertz. Okay. Now, if two additional elements are added to it to connect a dipole of same length, what will be its input impedance? So, again, here, what is given to you? A isolated resonant lambda by 2 dipole. You would remember that in previous class, I told you if a half wave dipole antenna is resonant, then its input impedance will become how much? Do you remember? I told you input impedance of this will become how much? 73 ohm.
73 ohms.
Yes, very good. So yeah, so isolated resonant antenna has a at 3 gigahertz. Okay. Now, if two additional elements are added to it to convert it into a dipole, into a folded dipole of same length, what will be its input impedance? So, what you have to notice here is the resonant half wave dipole is converted into folded dipole. One thing. Another thing, the length is same. The other two additional elements which are added have same length. No, I mean two additional elements are added so that the folded dipole has the same length. So this was a half wave dipole antenna. Okay, sorry. So a half wave folded dipole antenna was something. A half wave dipole antenna was something like this. Now it is something like this. Dipole of same length. So length L. If we take length as L, then this is also L. Okay. And what is asked? It's asked that what will be its input impedance. So we already know that input of impedance of isolated resonant itna is 73 ohms, right? Now, agar two additional elements are added to make it folded dipole, then the input impedance will be Z in N square R in, right? Here N is given as n is given as n is not given to you, but what is given to you? It is given that one element was already there plus two elements were added, right? Two elements were added, so total number of elements become how much? 3. So here n is equals to 3. R in you already know. Now you have to find out Z in. So this is the formula. uh, N you already know, R in you already know. Please tell me how much Z in will be. I'm giving you 1 minute.
Ma'am, answer A, 657.
Okay, very good. Yes, correct answer is 657. Very good. So all of you were able to solve this question. Yes. Doubt, I guess. Right? No doubt here. Okay. So let's go to next question then. So the question here says a three element array of isotropic sources has the phase and magnitude relationship shown. So this is how it is written. Uh, First isotropic source is kept here, second is kept here, third is kept here. Okay, and it has a spacing of d, and d is equals to how much? Lambda by 2. What will be the array factor? So uh, sir has already discussed with you this thing, that array factor for uh, if we take the first one as reference, then array factor is minus e j beta d cos theta minus j plus e minus j beta d cos theta. Okay. So from here you have to find out the array factor. Array factor. Okay. So first thing is electric field. So the far field electric field can be written as this, right? For three elements, far field electric field will be written like this, and array factor becomes, if you what you have to do, if you take out minus ki by r e to the power j beta r, if you take that common, you will get array factor as e to the minus e to the power j beta d cos theta minus j plus e to the power minus j beta d cos theta. Now, do you remember e to the power iota theta? What we used to write e to the power iota theta? E to the power iota theta can be written as cos theta plus iota sine theta, whereas e to the power minus iota theta can be written as cos theta minus j sine theta. The power iota theta can be written as cos theta plus iota sine theta. Do you remember that? Right? E to the power minus iota theta is written as what? Cos theta plus cos theta minus j iota, j or iota, whatever you want to say, j sine theta. So this is what has been done here. It is converted into the whole thing is to j sine and cos terms, and array factor comes like this. Now you have to find out the magnitude of the array factor. You have to find out the magnitude of the array factor. Have to find out the magnitude of this term. Will you be able to find out magnitude of this term? And that will be your answer. So try to find out the magnitude of this term. I'm giving you 1 minute. हेलो, हाँ जी बोलो. अच्छा, प्रिंट आउट लेकर के चेकलिस्ट से सब मिला लेना कि सब हो गया कि नहीं, और एक्स्ट्रा चीजें लेकर के चली जाना. मतलब जीजू का भी पासपोर्ट का फोटो का पासपोर्ट, आधार का कार्ड, और मेरा मांगेंगे तो मैं अपना भी दे दूँ. तो मैं अपना दे देती हूँ, तुम वहीं पे जाके प्रिंट आउट ले लेना. अभी तुम्हारे पास प्रीमियम लॉन्च रहेगा तो उनको बोल देना कि ये मेरा ये दे दो, क्या बोलते हैं. अच्छा ठीक है. हाँ ठीक है. ठीक है, दे देती हूँ उनको. हाँ, अ, सस्ता वाला है पर ठीक है, मतलब बुरा नहीं दिख रहा. और फिर बात करती हूँ तुमसे मैं. सब कुछ निकलवा लो, चेकलिस्ट एक बार सब कुछ चेक कर लो. चेक मारते जाओ, सब टिक करते जाना, जो जो होता जाएगा. ठीक है. हम्म. हेलो. हेलो. Done anyone? It's nothing, yeah. It's nothing. It's modulus of this, that is 2 sine beta d cos theta plus 1. Right? So that is what you were supposed to write for the array, modulus of array factor. This is what I asked you. Answer is D. Correct answer is answer D. Okay, so let's go. Is there any doubt? You guys have any doubt here? tell me how many of you, honestly, tell me how many of you have completed the the lectures from 16 to 20. Did anyone?
Ma'am, I have completed.
Yes, you have.
I have completed.
Okay, okay, very. Solve the question then. Not completed, yeah. Okay. I was just asking modulus of array factor, right? You could have solved it. Anyways, it's all right. It's okay. So you have one day still to go. So you will be able to solve this year's assignment, hopefully, and you will be able to score high there. Okay, that's why I'm here to,
Okay, ma'am.
yeah, to give you the nudge to solve the question and score high better. Uh, Anyways, so let's go and ask complete question number 4. So here question number 4 says, for a broadside linear array of 10 dipole antennas operating at 3 gigahertz with inter-element spacing of lambda by 4, what will be the beam width of the main lobe? Okay. So here a linear array of 10 dipole antennas is given. Okay. Operating frequency is given and inter-elemental element spacing is given. That is D is given to you. Okay. Lambda you can find out, right? And total number of elements is 10. Uh, 10 dipole elements are given to you. So here n plus 1 is number of dipole. So when if you have gone through SIR's lectures, you would know that the first dipole antenna at the origin, and then we start counting. So let's say if we have n elements and the first one is at 0, then this one will be, if we have n plus 1 elements and the first one is kept at 0, the last one will be kept at what? N, right?
From however, in many books we find that n equal to number of antenna is taken as n, so that the formula may be somewhat different. You find that by referring some book, we find that instead of n plus 1, the formula may be given as n.
Yeah, it actually depends on the length of the array. So if length of the array differs, like if it's not a linear array, okay, if it is a circular array, okay, then length of the array will be different. If it's a linear array, then length of the array will be different. So every, like if we have n elements, all right, so and all of them have a difference of, all of them have a distance between. So let's say, I will show you. So let's say we have 4 elements. Okay. So if we have 4 elements and they are kept in uh, array, right? And it has a distance, it has a spacing of d, right? If it is, how much will it be? Total distance L will be how much? Length of array, total length will become how much?
n plus 1 into d.
Oh,
n,
n minus 1
n,
into d.
oh, yes.
So this is 3D, okay? D, D, D. So this is 3D. So just to make, uh, the formula easier, and in terms of how much elements are there, if it is kept at 0, 1, 2, 3, right? So even though elements are 4, but if it is kept like on 0 on origin, 1, 2, 3. Now if n is equals to 3, right? Wait, if you won't be able to, yeah. So if let's say it is given that the last element is kept at 3, yeah. So if last element is kept at 3, you will be able to understand how many elements are there. Total number of elements are 3 plus 1. Okay. Are you getting the like the idea what I'm trying to tell you?
Yes,
Huh.
yes, madam.
Yeah, so just to make you can use different variables, you can do. So just to make the what we are doing, total length is 3D, right? And if we say this as n and total length becomes nd, this n can be said as the space between these two, so these elements. So space between these elements is 3, so total length is nd. So total number of elements will be how much? N plus 1. Getting? If we say that this space, if we count this space, then 1 2 3, 3 spaces are given. So length can be said as 3 space into d. So nd, total number of elements become how much? N plus 1. That will be equals to 4. Got it?
Yes, madam.
Okay. Okay. So anyways, so here for a broadside linear array of 10 dipole elements operating at 3 gigahertz with inter-element spacing of lambda by 4, what will be the beam width of main lobe? So beam width for, so here 10 dipole elements are given. Okay, it is in a linear array. All right, it is operating at 3 gigahertz and they have inter-element spacing of lambda by 4. Beam width is asked to you. Main lobes beam width is asked. So main lobes beam width can be written as 2 lambda upon n plus 1 into d. 2 lambda upon n plus 1 into d. So lambda is given to you, n plus 1 is given to you, d is given to you. Will you be able to find out bandwidth? Will you be able to find out the bandwidth? It's a it's a simple formula given to you. Lambda, d, n plus 1, all of the values are given. Try to find out the beam width. I'm giving you 2 minutes. Done, everyone? Solved? Okay, so about uh, the linear arrangement. So you, uh, like you said, this is linear arrangement, right? But if, let's say, the elements were kept like this, 1, 2, 3, 4, right? Now if the elements are kept like this, then what will be spacing between them? 2, 1, 2, 3, right? So here total number of element becomes equals to total number of the spacing in between them. So if elements are arranged in linear way, it will be space will like however like if the total number of elements are 4, then the space between them will be 3. So total length of the array will be 3D. But if these elements are not kept as in a linear format and kept uniformly from each other, have a are in place in something like this kind of arrangement, then the total length will become how much? N plus 1D, right? That is 4D. Okay, so if you see any difference in questions, and like you if you see different kind of formula what is going on, then you can find out, you can guess the answer, not guess the answer, you can understand by uh, knowing what kind of arrangement they are kept in. If they are kept in linear arrangement, if kept in uniformly with uniform feed or something like that, if what kind of arrangement they are kept in, by that value you will be able to check the change in the formula. You will be able to understand why the formula is getting changed. All right. So anyways, so here n plus 1 is equals to 10 is the number of elements, and d is the inter-element spacing. Hence, bandwidth will be 2 lambda upon 10, that is n plus 1, 10 d, that is lambda by 4. So how much it becomes? Becomes zero point 0.8. Zero point 0.8 is a zero point 0.8 radians. In terms of degree, it becomes 45.83 degrees. Okay, any doubt here? Anyone? Next option is D. Any doubt, anyone?
Yes, ma'am. I got a doubt, ma'am.
Hmm.
Yes, ma'am. The elements is at 10 and the plus 1, we cannot take it as 11, ma'am. Why we are going to take it as a 10?
Yeah, I told you na, they are in linear array. So if they are kept, so here and
Okay.
yeah, so here you have to think na, as I already told you here. See, if who is talking? Ilango is talking. So yeah, huh.
Yes, ma'am. Yes.
Okay. So it depends on what kind of arrangement they are kept in. Okay. If they are kept in linear arrangement, then what will happen? Then our n will be n plus 1 will be the total number of elements. If it is in linear arrangement, because the spacing between them, see, if let's say total number of elements are 4, okay, so elements are kept like this linearly, so 0 1 2 3 4, 0 1 2 3. If this is the origin, and it is kept at 0, then another one is at 1, another one is at 2, another one is at 3, right? Now the spacing between them becomes how much? D plus D plus D. So total spacing is how much? How much spacing it has? 3 cross D, right? So if we are counting n as the space between them, space between the elements, okay, then total number of element becomes how much? N plus 1. See, if it is kept in linear form, so 1 2 3, so space is 3, total number of, but total number of elements are how much? N plus 1. But if they are kept like this, let's say 4 elements are there, they are kept, they are not in linear form, right? They are kept something like this, all of them are getting uniform feed, but they are not in, see, if they are kept in linear form and uniform feed is given from this side, all the other elements will have different phases, right? But if it's something like this, feed will be uniform. So anyways, so the space between them is how much? 1 2 3 4. So 4 spaces are given, which is equals to the number of elements. Now here the formula is n plus 1d, right? But here the question says that it's a linear array of 10 dipoles. So if it's a linear array of 10 dipoles, total number of elements is how much? This n plus 1 itself is total number of elements. This n is not number of elements. This n is, you can say, the spaces between the elements. Got it?
Yes, ma'am. I got it, ma'am.
Yeah. Okay.
Thank you, ma'am.
Okay. Welcome. Yeah. Again. So again, a uniform line. Anyone else? Any doubt? No. Okay. So a uniform line array of 5 elements has a spacing d is equals to 0.4 lambda. Find the progressive phase shift in order to produce beam at 45 degree to the array axis, that is xi is equals to pi by 4. So here a uniform line array is given to you. Okay, this this uniform line array is given, and total how many elements are given to you? 5 elements are given to you. Okay, wait, better. A uniform line array of 5 elements has a spacing of d is equals to 0.4 lambda. Find the phase element in order to produce beam at 45 degree of the array phase to the array phase, that is at psi is equals to pi by 4. So 5 elements are given, spacing is given how much? 0.4 lambda spacing is given to you. Now you have to find out the progressive phase shift in the feed of these elements so that the beam produced is how much? Is beam produced is 45 degree. Okay, so you have to find out the phase shift given to the element so that the produced beam is 45 degree from the array axis. Okay, so something like this. You have to find out. Beam is how much? 45 degree. Anyway, you have to find out this. So first thing is to obtain main lobe at psi is equals to pi by 4, one thing that you have to see is u is equals to minus u naught. So this sir would have given this to you. So hmm, okay. So sir would have already told you in the class that for the main beam occurs as is if there is the plot, proper plot that I can show you instead of this one, since not very yeah. Sir in the class told you that the main beam occurs at u is equals to minus u naught. Why? This is at maxima, and he used some equations, and then he was able to find out that for maximum to occur u has to be u naught. Okay, so here so the main being main lobe at psi is equals to pi by 4 requires u is equals to minus u naught. Now the progressive phase shift can be written as minus k naught d cos psi. Now d is given to you, k naught is free space wave number, which is 2 pi by lambda, and cos psi. So psi here is pi by 4. So progressive phase shift equation formula is given as minus k naught d cos psi. Okay, so k naught is given, d is given, psi is given to you. Will you be able to find out the progressive phase shift? Do you have any doubt? If you have any doubt, go on, ask. No doubt. Okay, then solve this question. You will be able to find out the progressive phase shift. You know the value of k naught, d, and psi. Put all these values here and tell me what will be the correct answer, correct option.
I think C is the right option, ma'am.
Okay. What about others? What others think? Okay, I'm giving you 2 minutes. Solve this question. What about others? Someone trying to say something?
And whether we have to convert it into one sign
Yes, you have to convert.
radians to degree.
Yes,
Radians to degree we have to convert.
yes, yes. You have to convert that one.
Or can we put, instead of converting, can we put pi equal to 180 degree directly so that
Huh?
no need to convert?
Uh, yeah, yes.
I think it will come to 101, 101. That is the answer D.
Okay, okay. What about others? What others think? Okay, yes. So the correct answer is 101 dot 4 degrees. So here the answer, if you have used pi as 3.14, then you would have got it in radians. So you have to convert that into degrees. Okay, and if you have directly put pi as 180 degree, you will be able to directly get the answer, which is 101.4 degree. So the correct option answer here is answer D, minus 101.4 degrees. Okay, so let's go and try to solve next question. Design an ordinary end fire uniform and array with only one maximum so that its directivity is 20 dB above isotropic. Okay, the spacing between the elements is lambda by 4 and its length is much greater than the spacing. Determine the number of elements. Okay. Question 2. Overall length of the array. Okay. Progressive phase shift between the elements. Okay. So three things are asked to you. So here an ordinary end fire uniform array is given. Okay. And it has a one, it's a end fire, so only one maximum it has, and it has a directivity of 20 dB above isotropic. So that is given to you. Now the spacing between the elements is lambda by 4. Okay, and its length is greater than the spacing. Okay, now you have to determine number of elements. So the first thing you have to do is directivity of end fire is D is equals to 4.73 n plus 1 d by lambda. Okay, so this the directivity for end fire array. Now here the value of D is the actual value, but here it is given in logarithmic terms, right? It is 20 dB. So first convert your uh, directivity into normal value. Okay, and then put it here. You will be able to find out the value of n. Okay, got it? So here n, you have to find out n plus 1. N plus 1 is what? Number of elements. So total number of elements is n plus 1. You have to find out that d, in terms of db, is given to you, small d is given to you. How much small d is given to you is lambda by 4. Okay, so do it. First tell me the number of elements, how many number of elements will be there here. Take notice that it's a end fire uniform array. Okay, I'm giving you 2 minutes.
Hundred, madam. N equal to n plus one equal to 100. Bro.
No, d is equals to, d is equals to,
100, madam. N plus one equal to 100.
no, you have to solve it again. I guess you getting lost.
Ma'am, 84.5.
Yeah, so maximum number of elements can be how much?
100.
How many number of elements are there?
100, ma'am. 100.
No, 100 is not correct answer. So you have to put C. So
No, 4.
Ma'am, I'm getting
400
ma'am.
No,
yes,
400 divided by
400.
400 divided by 4.73.
Why are you?
Ma'am, where it is 400, only
Ah,
4.
From where is it?
No, only 4.
Yes, yes. So correct answer is total number of elements is 85. So n plus 1 came as 84.57. So we already know that number of elements are integer number. So maximum total number of elements can be how much? 85. Now you have to find out, so 85. Okay, now you have to find out the overall length of the array. So I have already told you here that once you find out the number of elements, how you will be able to find out the how many spacing are there, and what will be the total length of the array, right? So use that formula and tell me what will be the uh, length of the entire array. Okay, so you have to find out the length of the entire array. So first tell me what will be the length of the entire array, then we will yeah, do that.
21.
21. Okay, anyone else?
21, madam.
21. Yeah, okay, yes. So 21 is the correct answer. So as I told you here, n t, right? So n plus 1 is 85. So n is how much? 84. So nd will be how much? 84 into phi by lambda. You already know the value of d. D is here, lambda by 4. Tell me how much will be the progressive phase shift and which will be the correct answer. Answer B or answer C?
No, answer B.
Why answer B?
And five, five.
Yeah, but it is here plus minus, right? So progressive shift can be plus minus kd. Okay. What will be the correct answer?
D, plus or minus 90 degree.
Yes, very good. Yes, so the
D,
correct
ma'am.
answer,
D is the good answer.
huh? Anyone, someone
Plus
say?
or Ma'am, minus. D will be the correct answer.
Yes,
Plus minus 90.
yes, very good. So yeah, so total number of elements it will be 85. Overall length will be 21d, and progressive phase shift between the elements will be how much? Plus minus 90 degrees. So formulas are already, I already discussed. I gave you the hint, and this was the answer. This is the answer. Answer D. Anyone has any doubt here? Okay, I will be muting you. Thoda sa there is noise little bit, so I have muted you, Ilango. Okay, so let's go and try to solve next question then. Yeah. So here, design a uniform broadside linear array. Okay. See, here again, it's a linear array. Design a uniform broadside linear array of n elements placed along z-axis with uniform spacing d is equals to lambda by 10 between the elements. Determine the closest integer number of elements so that in the elevation plane, the half power beamwidth of the array factor is approximately 60 degrees. Okay, so here a broadside linear array of n elements is placed along z-axis with uniform spacing d is equals to lambda by 10 between the elements. Okay. Now it's asked that determine the closest integer number of elements so that in the elevation plane, okay, in elevation plane, the half power beam width of the array factor is approximately 60 degrees. So again, half power beam width of a uniform broadside linear array of n plus 1 elements is given by 2.65 lambda upon n plus 1 pi d. Okay. Yeah. Okay. So, huh. So, broad half power beam. The formula for half power beam width can be given as 2.65 lambda upon n plus 1 pi d. N plus 1 is number of elements. You know the half power beam width, right? Half power beam width is how much? 60 degrees. Put 60 degrees here. Lambda you know, pi you know, d you know. D is how much? Lambda by 10. So you know all the other values. Will you be able to find out the value of n? It's a simple arithmetic equation now. Solve this question, okay? And tell me the value of n plus 1.
Ma'am, answer option A will be correct.
Option
A.
A. Yes. What about others? Okay, so try to solve it and I'm giving you 2 minutes. हेलो हाँ बोलो अच्छा हाँ हाँ अरे मैं अभी क्लास ले रही हूँ यार 9 बजे तक भेज पाऊंगी अ,
Yes, ma'am. N plus 1 equal to approximately 8 plus 1, 9, ma'am.
हाँ हाँ क्या बोल रही हो हाँ ठीक है Yes. So the correct answer is option C. Very good. So yeah, again, so n plus 1 came as 8.005 and we know that it needs to be the greatest integer, nearest greatest integer and so the total number of elements become how much? 9. Now question number 9.
Madam,
Ah,
madam, n plus 1 equal to is then why you have to take approximately to 9?
yeah, because it's a greatest integer, nearest greatest integer is what we take. So here it is asked that determine the closest integer number of the elements so that in elevation plane the half power beamwidth of the array factor is approximately 60 degrees. So when it says closest integer, for array you have to take the greatest closest integer. Okay, greatest closest integer you don't, so if it's 8.055 you take 9, if it is 8.00055 then also you take 9. Okay, because if see if we take 8 then the half power beam width won't be 60 degree, it will be more than 60 degrees. And if we take 9 then we can say that yes, half power beam width will be around 60 degrees. We taking 8, we will be taking 9. Okay, hello. Okay, uh was I able to explain your doubt? Okay, chalo. So which of the following is not a correct statement? Okay, so it's a not a correct statement, so we have to find out an incorrect statement. For the same number of elements, the beam width of a uniform broadside array is broader than that of a uniform endfire array. So here it is saying that if there is same number of elements, the beam width of uniform broadside array is broader than that of uniform endfire array. Okay. Second statement is Hansen-Woodward condition utilizes invisible region to get maximum directivity. Okay. Third option is main lobe occurs when u is equals to minus u naught. Fourth option is visible region of an array is limited due to grating lobes, or generally we try to avoid grating lobes in visible region. So what you all think, is which statement is correct answer, correct statement, which is incorrect statement? What do you think? Yeah, option A is incorrect. Okay, why? Okay, so uh, end fire arrays, the beam width for the end fire array is broader than the beam width of uniform broadside array. This has been discussed with you in the lecture, right? In array factor. So in the lectures, uh, lecture number 20, it would have been discussed with you that the beam width of uniform broadside array is generally narrower than the uniform end fire array. Okay. Another thing is, thing to notice is, can you tell me if I increase the number of elements in a array, will it narrow the beam of uh, will it narrow the beam width or will it broaden the beam width? What will happen?
Ma'am, it will be narrower.
Yes,
It
yes,
will be narrow. It will be narrow.
yes, very good.
That's why we are using array concept.
Yes, yes, very good. Okay, so I'm yeah, that's very good, correct. So as we will be increasing the number of uh, elements in the array, we will be getting narrower bandwidth. Okay. Statement B, Hansen Woodward. So yeah, so you already got that option A is the incorrect option statement. Do you have any doubt? I have already told you statement C. We discussed this in previous questions, I guess. Yeah, here question number 6 we discussed. So I have already discussed this with you. Yeah. So visible region of an array. So reason is restricted to the before the grating lobe. So before the grating lobes comes, visible region is restricted to that. Yeah, here. So you can say that this is the grating lobe, which is almost in comparison to the main lobe. So our visible region is how much? Till this one. We don't take the grating lobes region. Okay. And yes, Hansen Woodward condition utilizes invisible region to get maximum directivity. Yes, this statement is correct. Now let's go to. Do you have any doubt, anyone? No. Okay. So let's go to next question then. Yeah. Following is not a correct statement. In a uniform linear array, the first side lobe is 13.5 dB down from the major lobe. Okay. Second option is the visible region of a uniform linear array is sorry. The visible region of uniform linear array is given by plus minus 2 pi d by lambda naught. Okay. The progressive phase shift required for an end fire array is plus minus 90 degrees. The progressive phase shift required for a broadside array is 0 degree. Okay. So I I have already discussed this in the class today. One of the statements I have already discussed with you in the class, and you can tell me which is the incorrect. I'm pretty sure that you will be able to tell me which is the incorrect statement. Go ahead, tell me. Okay, I already discussed with you that the progressive phase shift required for end fire is plus minus kd. I discussed it with you, right? Here it was an end fire. It was an end fire uniform array, and the progressive phase shift is will be how much? Plus minus kd. I discussed this with you. So here the option is this one. That the progressive phase shift required for end fire array is plus minus kd, not plus minus 90. The statements are correct. This is already discussed with sir. Sir told you that the first side lobe level is 13.5 dB down. I guess in this lecture number 9, he discussed it with you. 19, sorry, lecture number 19, he discussed uh, this statement. Wait, where is it gone? And is it discussed in lecture number? No, lecture number 19 itself it was discussed. Okay, I'm not able to find out where it has gone now, or was it discussed in lecture number 18? Wait, let me check. Plus minus pi. Yeah, so, and also he discussed visible reason, which is given by 2 pi plus minus 2 pi d by lambda naught. So this is correct option. This is correct answer statement. This is correct statement, and this is also correct statement. I'm not able to find out the first statement, but yes, 13.5. He was able to solve this question. He was able to solve it for this question. Once introduction of NPTEL EE. Was it in this one? Okay, I'm not able to find out. Uh, Anyways, so if you have not, yeah, so the wrong answer is, uh, sorry, the wrong statement is option C. Here it's a plus minus kd. Plus minus kd is the correct answer. We have discussed this in question number 7 with you. So, one, oh shit. Sorry. Sorry, my call dropped. So, anyways, yeah. So I already discussed with you statement C. So first, one thing that I want to emphasize is go through the lectures, read them, make notes of them. Okay, then only you will be able to understand my live sessions, and then only you will be able to solve the assignments. Okay, so I really want you to not have a backlog and go through the lectures. Okay, backlog of lectures, not backlog in the course. I really want you to not be left behind. Okay, and solve the question. So, anyways, do you have any doubt in any of the questions that we discussed? Ilango, Brianna, is your
Yeah, yes, ma'am. Lango. No, no doubt, ma'am. But could you provide the link in YouTube, ma'am? Because I want to go through by YouTube your notes and solutions because I'm took in that what assignment very low mark, ma'am, past three assignments.
okay? All
Please,
right,
ma'am.
all right, okay.
Yeah, could you provide the link, ma'am?
Acha, you want me to provide it right now? Okay, one second.
Yeah.
Yeah, so I have given you video of my previous lecture, so you can go through it. You can then go to my channel and check out all the other lectures. Okay. What about others? Do you have any doubt anywhere, Brianna? Okay, so I guess no one has any doubt. Uh,
No, madam.
yeah. Okay. All right. So yeah, again, so if you have any doubt, you can put it in my comment section, and yeah, I will, if I get some time, I will be able to reply you there. Okay, and all the best for your assignment 4. Okay, I want you to get good marks there. Okay.
Madam, is it
Thank you.
previous year question papers are available? Whether in the website previous session, previous year question paper.
Previous.
I think 2 years back it is this course is conducted.
Yeah.
I
Yes.
think
Yes.
whether that question is available, not.
No, it won't be available to you. Most probably, the course will be available to you, but I am not sure if previous year questions and assignments are available to you. So since see, what happens is generally the question, the type of question will be almost similar to the questions that you will get in your assignment. So then if the assignment and solution is already provided to you, then like what students will do is they can just copy the answers, then they can do that. So rather than doing that, they do the live session so that you get through the teaching, you get to understand what you have to do, what you have, which formula you have to use, and then you solve the question assignment. Okay, so I'm not sure if previous year's question paper and assignments question paper and solution is given to you. I'm not sure, but most probably it won't be provided. Anyone then has any other doubt? Welcome. No? Okay, then. So let's end this session and let's end the session. Bye bye. All the best and bye bye.